All right, so today we're going to be factoring, and there's two types of factoring that we're going to be doing for today. Tomorrow and in the future you may be doing additional types. But mainly today you're going to be either looking for a GCF or a greatest common factor, or you're going to be factoring a trinomial, or you may do both at the same time. So you can pause the video if you need to write down the notes, but we'll refer back to those in a minute. So the first thing you're going to look for is a greatest common factor, which could either be a number, a variable, or both. So in problem number 1, it says 4x plus 12. We're going to see if we can divide both 4x and 12 by either the same number or by a variable. So you can divide them both by 2, or 4. But I want the greatest one, so since the word greatest means the largest, I want to divide them both by 4. Okay. So I'm going to divide them by 4. 4x divided by 4 is just x, and 12 divided by 4 is positive 3. And the thing that I divided out has to go on the outside. So essentially, if I were to distribute the 4 back in, 4 times x is 4x, 4 times 3 is 12, I would get the original problem. So you're essentially just dividing. That's what factoring is. But whatever you're left with here should multiply back to give you your original problem. All right, so problem number 2, we're going to do looking for a GCF first. Okay, what can we divide all 3 of these terms by? Well, we could divide them by 2 or 4, same thing as what we did in the last problem, but I want the largest number, so I'm going to divide them all by 4. All right, so my 4 is my GCF, and then I need to write what's left over. So I have 2x squared plus 4x plus 3. All right. Then it says if a trinomial remains, we're going to try to divide that trinomial into 2 binomials. For today, a is going to equal 1, so it'll just have x squared. There won't be a number in front. So right now, because there's a 2 in front, we don't need to do anything else. So for today, we're going to be done. Tomorrow, we're going to be dealing with problems where you have trinomials and there's a coefficient in front that's not 1. Okay, so we're going to keep going. Number 3, we're going to divide by a GCF. Now, I could divide by 3. You can always divide by 1, but that's not really going to help you change the problem. However, if I just divide by 3, I'm going to be left with a negative in front, so I don't want to do that. I want to divide by negative 3. So that way my GCF is negative 3. It says up here, if the lead coefficient is negative, then the GCF must also be negative. All right, so negative 6 divided by negative 3 is 2x squared, and 3 divided by negative 3 is negative 1x, or just x. Now notice that what's left is there's still something that I could divide by. So I could have taken out an x out of that as well. So really my GCF should be negative 3x, because there's still an x left over. 2x squared divided by x is 2x, and x divided by x is negative 1. So this should be my final answer. It would have been easier had we done that from the beginning, just save ourselves a step. If I noticed that, okay, I can divide them both by negative 3, and since they have a common variable, I could divide them both by negative 3x. And then that way I could have just gone straight to the final answer. Okay? All right, number 4, my GCF. Can I divide them all by something? Well, I could divide these by 2, but that one can't be divided by 2. If I divide them all by 1, that doesn't really change anything. Okay, so I'm just looking at x squared plus 6x plus 8. All right, you don't have to do that if there's just a GCF of 1. Now we're going to look at the trinomial. If it's a trinomial and a is 1, that means it's just x squared. We're going to divide it into 2 binomials. Binomials have 2 terms. The only thing that's going to multiply to x squared is x times x. So we know it's going to be x times x, and then I need to look at numbers that multiply to 8 that add to 6. All right, so they multiply to the last number, which is c, but they have to add to the middle number, which is b. All right, so things that multiply to 8, we have 1 times 8, negative 1 times negative 8, 2 times 4, and negative 2 times negative 4. All right, but if I were to add them, this adds to 9. This adds to negative 9, 6, and negative 6. I needed to add up to that middle term, which in this case is 6. So what I want is these two values. All right, so those two values will go here. And we can check by multiplying. If I were to do first times first, I get x squared. Outer times outer is 4x. Inner times inner is 2x. And last times last is 8. If I add those together, that gives me 6x. Okay, but this is actually my answer. All right, so flip over to the back. We're going to keep going with some more examples. All right, number 5. First look for a GCF. I'll give you a hint. If there's no coefficient in front of x squared, then there's not going to be a GCF. So we're just going to look for two binomial factors that we can divide the trinomial into. Since it's x squared, I know that it's going to be x and x. So now I need to look at what multiplies to negative 24. Well, I could have negative 1, positive 24, or vice versa. I could have negative 2 and 12, or positive 2 and negative 12. I could have negative 3 and 8, positive 3 and negative 8, negative 4 and 6, or 4 and negative 6. All right, so I need to add these two terms to get me negative 5. Well, that's going to add to 23, negative 23, 10, negative 10. That's 5, but I need negative 5, so I want that. That means that I need a positive 3 and a negative 8. Okay. Then we're all done. All right, number 6. Same concept. There's no GCF because there's just a 1 right here, so I can't divide it by anything. I need to multiply to negative 24. Well, I have this same list. I just made it, so I don't need to rewrite it. This time I need something to add to positive 2. Right? We said this adds to 23, negative 23, 10, negative 10, 5, negative 5. That was what we wanted in the last problem. Here we want 2 and negative 2. We want to add to 2, so I need that one. Right? So negative 4 and 6. That means I'm going to write x minus 4 and x plus 6. And I'm all done. All right, so remember, you're looking for a GCF. Can you divide them all by some number? Well, this divides by 2, so I'm left with x squared plus 7x plus 12. And then I need to figure out there's 1, 2, 3 terms, so that I'm going to look for two binomials that multiply to give me this. So I have two numbers that multiply to 12 but add to 7. All right, so if you write down your factors, don't forget about the negative factors. All right, but if they're going to add to 7, I know it's not going to be any of these negative ones. I need to add here. So 3 and 4, that means plus 3 plus 4. Okay, problem number 8. What's the number we can divide them all by? 3. Notice that it's just 3, not x, because this doesn't have an x in the last term. So 3 is out on the outside. Then we have x squared minus 1x minus 20. All right, and then if I look at the last number, I need numbers that multiply to the last number but add to the middle number. Okay, so multiplying to negative 20, we have negative 1 and 20. We have negative 2 and 10. We have negative 4 and 5. And I switch the negative sign around, so you could have 1 and negative 20, 2 and negative 10, and 4 and negative 5. All right, I need to add to negative 1. Well, these are far apart, so I know it's not that. These are going to add to 8 or negative 8. This is 1 or negative 1. Make sure you pick the correct one. We want to add to negative 1. So it's 3 times the quantity x plus 4 and x minus 5. All right, number 9. Now, normally I would say there's no GCF, but it's got that negative sign there, so I don't want to leave a negative in front. I'm going to divide them all by negative 1. So I take out a negative 1. I'm left with x squared plus 5x plus 6. All right, now I have a trinomial. There's just a 1 in front, so I look at what numbers multiply to 6. 1 and 6, 2 and 3, or the opposites. Okay, so what multiplies to 6 that adds to 5 is that one. So x plus 2, x plus 3. You can really leave off the 1. It could just be negative x plus 2 and x plus 3. But this answer is fine too. All right, last problem. GCF, what can 5, 10, and negative 40 be divided by? Is 5. What I'm left with is x squared plus 2x minus 8. Okay, there's a just an x squared, so we go ahead and look at what multiplies to negative 8, which is 1 and negative 8, negative 1 and 8, 2 and negative 4, and negative 2 and positive 4. All right, now we want to look at what adds to 2. This adds to negative 7, positive 7, negative 2. This one is positive 2. So that's the one we want. Okay, so by the way, these binomials don't have to be in any particular order, so you could say x plus 4, x minus 2. That would be fine as well. The 5 should be in front, and then you just do have to be careful of your sign. So this should be a negative 2, no matter where you put that, and then 4 has to be positive.